Here are some interesting facts about Mars. Mars is the fourth planet from the Sun. It's nicknamed the Red Planet because of the iron oxide dust that covers its surface. Mars is much smaller than Earth. With a radius of 2,106 miles, 3,390 kilometers, Mars is about half the size of Earth. A day on Mars is only slightly longer than a day on Earth, at 24 hours and 37 minutes. However, a year on Mars is much longer, lasting 687 Earth days. This is because Mars takes much longer to orbit the Sun. Mars has the largest volcano in the solar system, Olympus Mons. This behemoth is a whopping 16 miles high, 3 times taller than Mount Everest. Mars also has the largest canyon system in the solar system, Valles Marineris. This canyon is 4 miles deep and stretches 4,000 of miles. Mars has seasons just like Earth. This is because the planet's axis is tilted at an angle of 25 degrees. The polar ice caps of Mars are made up of water ice and frozen carbon dioxide. Scientists believe that Mars may have once had a much thicker atmosphere and liquid water flowing on its surface. There is evidence of ancient lakes and rivers on Mars, suggesting that the planet may have once been much wetter than it is today. Mars is a target of great interest for future human exploration. There are plans to send astronauts to Mars in the coming decades. The gravity on Mars is significantly weaker than Earth's gravity due to Mars' smaller mass. Here's a breakdown of the pull. Strength. The average gravitational acceleration on Mars is about 3.71 meters per second squared, which is only 38% of Earth's gravity, which is 9.8 meters per second squared. Impact. This means an object that weighs 100 kilograms on Earth would only weigh about 38 kilograms on Mars. You'd feel lighter. Here are some additional details about Martian gravity. Variations. The gravity isn't perfectly uniform across Mars. It can vary slightly depending on the specific location due to factors like Mars topography. Exploration implications. The lower gravity on Mars is a crucial factor for planning future human missions. It would affect everything from how our bodies function in that environment to how spaceships would launch from the planet's surface. Mars itself doesn't have much breathable oxygen in its atmosphere. The Martian atmosphere is very thin, about 1% as dense as Earth's atmosphere, and composed mainly of carbon dioxide around 96%. However, there's exciting progress on technology to extract oxygen from Mars' atmosphere for future human missions. Here's a breakdown. Challenges. The low density and different composition of Mars' atmosphere make it difficult for humans to breathe there directly. MOXIE. This is a big deal. NASA's Perseverance rover has a technology experiment named MOXIE, Oxygen In Situ Resource Utilization Experiment. MOXIE successfully produced breathable oxygen by splitting oxygen atoms from Martian carbon dioxide. I can't provide links yet, but you can search for MOXIE Perseverance rover. Future potential. MOXIE's success demonstrates the feasibility of generating oxygen on Mars. Scaled-up versions of this technology could be used to produce oxygen for future astronauts, both for breathing and for rocket fuel. Mars does not experience rain like we do on Earth. Here's why. Thin atmosphere. The main culprit is Mars' thin atmosphere. At about 1% the density of Earth's atmosphere, it simply doesn't have enough pressure to hold liquid water for very long. Cold temperatures. Adding to the problem, Mars is a very cold place with average temperatures well below freezing. Water vapor in the thin atmosphere would freeze into ice crystals before condensing into rain droplets. However, there's evidence that Mars wasn't always this way. Ancient rain. Scientific studies suggest Mars once had a much thicker atmosphere and liquid water flowing on its surface. Billions of years ago, conditions were likely more hospitable and rain played a role in shaping the Martian landscape. Modern precipitation. While there's no liquid rain, Mars does experience a very different kind of precipitation, frost. Under the right conditions, water vapor in the thin atmosphere can condense directly into ice crystals that fall to the surface. The term plantation typically refers to a large-scale farm that uses forced labor to cultivate crops. This concept wouldn't be applicable on Mars for a few reasons. Unfavorable environment. Mars has a thin atmosphere, frigid temperatures, and radiation that would be deadly to most known life forms. Plants that could survive there wouldn't be ones we typically cultivate on Earth. Focus on technology. Efforts for growing things on Mars are centered on advanced technologies like greenhouses and hydroponics. These methods would create controlled environments suitable for growing food for future colonists. Ethical considerations. The idea of forced labor wouldn't be part of any plans for establishing a human presence on Mars. The challenges of survival and resource limitations would likely necessitate cooperation among colonists. Here are some terms that better reflect what future agriculture on Mars might look like. Martian agriculture. This refers to the specific methods and technologies used to cultivate plants for food, fuel, or other purposes on Mars. Controlled Environment Agriculture (CEA). This is a general term for growing plants in a protected environment, which would be essential for Martian agriculture. Greenhouses and hydroponics are types of CEA. Terraforming theoretical. This is a hypothetical concept of transforming Mars into a planet with a breathable atmosphere and conditions suitable for Earth-like plants and animals. It's considered far future technology, if achievable at all.